In this part of the lecture, we'll be talking about changing numbers from scientific notation to standard form and from standard form back to scientific notation. First, let's look at converting scientific notation to standard form. This is more straightforward. Now this is an example of scientific notation. Scientific notation, just to give you some notes on it, is first of all always multiplied by the base of 10, and the exponent changes depending on how big or small the number is and how many times we move it. And we'll look at that. We'll look at that as we go on. The other thing you need to realize is that basically this is just a short version of writing the number as really big number or really small number. So in this case, we have 7.1 times the power of 10 to the negative fourth power. And again, scientific notation always uses the base of 10. Now what's going to happen here is we're going to first look at where the decimal is currently placed. And secondly, we need to look at the exponent. This exponent is going to tell us two things. One, how many times we're going to move the decimal. And secondly, it's going to tell us in which direction to move the decimal. So, let's look at what we have here. Let's rewrite just the 7.1. Now, first things first. The negative 4 tells me that I need to move the decimal in the negative direction, which is to the left. The fact that it's a 4 tells me I need to move the decimal 4 places. So, right now the decimal is behind the 7. So when I move it 1 place, that brings me here. I still need to move it 3 more times. So that means I need to add 3 zeros. 1, 2, 3. So me changing 7.1 times 10 to the negative 4, which is scientific notation, to standard form will look like this. This is my number in standard form. Now standard form just means a regular number, a decimal, a whole number. Now this scientific notation also needs to be changed to standard form, but notice the difference. In the previous problem, the exponent was negative, so we moved the decimal to the left in the negative direction. Now the exponent is positive, so we're going to move the decimal in the positive direction the amount of times that exponent tells me. So with my number 8.5, again, we need to look at where is the decimal currently. I know how many times I need to move it because the exponent is 5, and I also know which direction I should move it in, which is the positive direction. So from here to here is 1 place. I still need to move the decimal 4 more places. So I'm going to add 4 decimals. 1, 2, 3, 4. 4 zeros, excuse me. So 1, 2, 3, 4. So now my number in standard form looks like this. So as you can see, what's happening here is scientific notation is being converted into standard form. So basically scientific just represents another way to write this really big number. Just as in the previous problem, this was another way to write a really small number. Okay, so again, converting from scientific notation to standard form is pretty straightforward. The exponent tells you whether to move in the positive or the negative direction and how many. Now, when we go from standard form to scientific notation, that's when it can be a little bit tricky. It's not as straightforward. It's actually the exact opposite of what we've been doing. So let's look at some examples like that. Let's say we have a number like 0.000023. This is currently in standard form. What we want to do is make it into scientific notation. So one of the first things you need to remember is you want to move the decimal as many times as you need to until there's one number in front of the decimal. And that number cannot be 0. Okay? So in this case, if I want to move this decimal until there's one number in front of it, I have to keep moving it until I get 2 in front of the decimal. So let's see how many places that is. From here to here is 1, 2, 3, 4, 5 places. So I need to move my decimal 5 places. So that tells me one thing. So far my problem has become 2.3, and that's because I moved the decimal until there's one number in front, which is the 2, times 10, which is always the base. Now the question is, what exponent do I use here? And this is where a lot of students get confused. They think that since they moved in the right direction towards the positive side of a number line, that the exponent should be positive. But in reality, this exponent, and it's going to be a negative 1, 2, 3, 4, 5. What you have to keep in mind is that this scientific notation is representing a really small number. If you look up here, if you had $0.000023, you really don't have too much money. It's a really small number. Therefore, when that small number in standard form gets translated into scientific notation, has to be represented by negative exponents, because negative exponents with really small numbers. Now let's take that concept and let's look at a really big number. For example, a really big number like, I don't know, 975,000. Okay, this is also standard form, but if you notice in this problem, the number's really, really small. In this problem, the number's really, really big. Again, you have to know where the decimal is. In this case, this is a whole number. So the decimal is actually at, we still have the number. Now we still have the same problem that we want to do. We want to move this decimal until there's one number, only one number in front of it. Okay? So in this case, we're going to move the decimal to the left so that we can get one number in front of it. So from here to here is 1, 2, 3, 4, 5. If I move it 5 places, I'll have one number in front of the decimal, which is 9. So far, this is what I have. 9.75. Again, we always multiply by powers of 10. Now you just have to figure out, what exponent do I use? First, ask yourself, how many times did you move the decimal? 1, 2, 3, 4, 5 times. Now, since even though I moved in the left direction, which is towards the negative side of the number line, I'm going to have a positive exponent. Again, because this number is representing a very large number. So with large numbers go positive exponents. Just like over here, where small numbers went with negative exponents. Now this is something that's going to take practice, and once you do it a couple times, you should get used to it. But just pay attention to your numbers and you should be fine.